Good morning, everybody. It is great to be with you today. I know I am not Jeff, but I'll be filling in for him. I'm a little too short to be him. So, this morning, though, I would like to talk to you about this topic, God and the cosmos. Now, my lesson today will not be super biblical in study, in which we'll not be observing many texts in the Bible or passages or verses, but it has a great scientific foundation in that it is observations of the universe. And it's mostly going to be pointing to the hand of God, to God's design of the universe. And a lot of it will be pointing to the age of the universe, because that is a big belief in our world today, that the universe is billions and billions of years old. Now, if an atheist was to come to you, or somebody that doesn't believe in Christianity, and was to ask you why you believe what you believe, of all the topics that you could use, or at least for me, of all the topics that I could use, the cosmos would not have been one that I would have thought of. I would have looked at design here on Earth, but I never thought of outer space as a good topic for proving God. But I hope that after my lesson today, you will agree that it is a fantastic topic to use to prove and show the design of God. So with that being said, I have a series of 6 points that I would like to present to you today. These 6 points are short period comets, planetary decay, lunar recession, galactic spiral winding, Saturn's rings, and the James Webb Telescope. So I'll be starting with short period comets, and I apologize, it's off-centered, that circle is. I made these slides on Google Slides, and then I downloaded them on PowerPoint, so it kind of got a little messed up there. So, short period comets. You might be wondering, what are they? They're pretty simple. Short period comets are comets that complete a rotation around the sun within 200 years. Now, most of these comets orbit from anywhere from 3 to 20, that's where the majority of them are, but a short period comet is defined as a comet that orbits the sun within 200 years. Now, examples of these comets include Halley's Comet, Encke's Comet, and the Swift-Tuttle Comet. So, why do these comets matter? Well, due to their small size, they're much less structurally sound. So when they complete an orbit around the sun, they don't complete a nice perfect circle. They complete long ovals, and when they come in closer to the sun, they're less structurally stable, and so solar radiation and solar winds from the sun cause them to break apart. This results in the lifespan of these comets being up to 10,000 years old. Now, there's far more than just the 3 of these comets that I mentioned earlier. There is actually about 2,000 in our solar system, and there's speculated to be up to many trillions within the Milky Way alone. Now, we see that the universe is littered with these comets, so you can't scientifically brush this off as some outlier. They demand an explanation. Okay. And the big problem with these comets is that there is no clear origin of them. So that's where this is leading, is that we see these comets everywhere, and there's not a clear origin for them. Now, the problem with that is that according to evolutionists and atheists, our solar system is supposed to be 4.5 billion years old. Now, if the solar system is that old, then all of these comets would have deteriorated in 10,000 years, which would have been billions of years ago. So the fact that we see these comets at all shows that they were created with the universe, and if their lifespan is 10,000 years, then that would point to the universe being within 10,000 years old. My next point will be planetary decay. Now, planetary decay, you might once again be wondering, what is planetary decay? So, I'm sure most of you know that Earth has a magnetic field. Now, most planets have a magnetic field, and the magnetic field protects these planets, and ours protects Earth from being scorched by solar radiation, cosmic rays, and being hit by meteors. It also allows an atmosphere to form, and it helps you navigate the planet by using a compass, which is north and south. Now, planetary decay is something that has been observed in most notably our magnetic field, but it's also been observed in other planets' magnetic fields as well. So our magnetic field has been observed to be weakening at an astounding rate. Scientists have been observing that Earth loses 5% of its strength, its magnetic field loses 5% of its strength every 100 years or every century. Now, scientists began measuring this in the 1800s, and we have seen that the magnetic field has lost 10% of its strength since we started measuring it. Now, evolutionists claim that the Earth is 4.6 billion years old. The problem with that is if you were to, Earth has had its magnetic field. According to them, they can somehow, I don't understand how it works, but their geologists can look at the layers of the Earth and somehow they can tell there's signs of a magnetic field in the layers of the Earth. Now, according to them, the magnetic field has been around for 3.5 billion years. So, according to them, about 1 billion years after the creation of Earth. But if the magnetic field existed then, you would have to go back, adding 5% of its strength every 100 years up to that point to find out how strong the magnetic field would have been at when Earth gained it in order for it to be at its strength today. Now, what you would quickly find is that the magnetic field would be impossibly strong. So, the magnetic fields in general, whether planetary or just a regular magnet, are measured in what is called Gauss. Now, Earth's magnetic field is measured in has a measurement of 0.4 Gauss. Now, if you go back 3.5 billion years, adding 5% of its strength every 100 years, by the time you got back to 3.5 billion years, Earth would have a Gauss rating of 10 with an exponent of 1.6 million, which is about a 1 followed by 1.6 million zeros. More zeros than I could fill up this screen with. So, it's just a small problem with that, is that at 10 billion Gauss, atoms are torn apart from each other. Now, what that would mean is if Earth's magnetic field was this strong, it would have completely turned all of its atoms into plasma. It would have completely exceeded the Planck energy scale and broken every single rule in physics and every rule of our physical reality. Now, here is a funny picture of what Earth would look like only at 10 million Gauss. As you can tell, this would not be an ideal place for life to form according to the evolution timeline of things. So you might be thinking, well, that's cool, but what causes this decay? Well, it all stems back to the second law of thermodynamics. Now, the second law of thermodynamics states that everything is constantly becoming more disorderly. It's in a constant downslope. So you can think of that as who here owns a car or owns a house? Now, how often do you have to bring in your car to be repaired? Or how often does your house get a leak? Or you have to call in a repairman to fix something, right? That's the second law of thermodynamics happening, which is everything keeps breaking. Now, you have to act to prevent that from happening. You can fix it up. But without you fixing it up, it's going to keep deteriorating. Well, this same law is applied to the Earth itself. Now, within Earth's core, there is a layer of Earth called the geodynamo. Now, this is in charge, or not in charge of, but this is what creates the magnetic field, because it is a layer of liquid iron that moves around, and it causes it's what causes the magnetic field to form. But it's scientific. I'm not doing a good job explaining. But over time, because of this second law of thermodynamics, Earth is starting to cool off. Its core is losing heat. Now, heat is a part of energy. And so as it's losing heat and it's cooling off, the liquid is slowing down, which is causing our magnetic field to weaken. Sorry about that. So here I have two pictures to help you visualize what I'm talking about. Here we have a picture of the Earth's layers up to the core, and I have circled the geodynamo section of it. And then I have this picture, which represents the actual magnetic field itself. As you can see, within the geodynamo, it's completely jumbled up, and then the blue section represents the northern pole, and the orange section represents the southern pole. So, our third point that we will go into is lunar recession. Now, who here loves the moon? I know I personally love our moon, but I have bad news for all of you. The moon does not love you. It is, our moon is moving farther away from Earth every year. Now, don't tell anybody, but I think it might be because Earth farted. Every year, the moon drifts 1.5 inches away from Earth. Now, it doesn't sound like a lot until you calculate how long they think the Earth and the moon have been around. So they think that the Earth has existed for 4.6 billion years, and the moon has existed for 4.5 billion years. Now, if this was true, you would have to go back 4.5 billion years and subtract an inch and move the moon an inch and a half closer to Earth every year. But what you would find is that the moon would have had to start inside of Earth in order for it to be at the distance that it is today. Now, that is obviously physically impossible, but conservative models have suggested that the moon could have just been extremely close to the Earth. But this is still problematic, because if the moon was that close to the Earth, well, the moon would have had such a strong gravitational pull on the surface of the Earth that it would have caused huge tidal waves to occur, and it would not have been able to support life on Earth, which again is crucial in the evolutionist view, because life would have had to evolve over the course of millions of years. Of course, this is very possible if the Earth is younger than 10,000 years. Our next topic will be galactic spiral winding. Now, there's a major problem for scientists with the way that the galaxy rotates. Now, who's familiar with what a galaxy looks like? Sure, we've all seen pictures of them. They rotate in spirals. Now, this is because of gravity, right? It's pretty simple. Gravity pulls it in and it just rotates, everything rotates. And because they're in spirals, this gives them their, what we call arms, and you can see arms are right there. Now, the reason why they get these arms is because not everything rotates at the same speed. So if you take our solar system, for example, and you think of Earth, okay, now we measure time through a year, right? And a year is how long it takes Earth to do one rotation around the sun, which is also 365 days. Well, if you think of a planet like Mercury, which is much closer to the sun, how long does it take it to rotate the sun, complete one orbit, or 1 year on Mercury? Well, it's equivalent to 88 days on Earth. Not that long, because it's much closer and it's got a much shorter distance to travel. Whereas if you take a planet like Neptune, and you see how far they have to travel, well, it takes about 60,190 days on Earth, which is equivalent to 165 years on Earth in order to orbit the sun one time. And why is this? Well, because if you compare them, clearly Neptune's got a much longer way to go. Well, the same rule applies to galaxies. Stars that are much closer to the black hole that they orbit have a much shorter distance to go around than the stars on the outside. And so as they go around, they move quicker, therefore creating this spiral or this arm. So what's the big deal with that? What's the problem? Well, galaxies are supposed to be 13 billion years old. But if the galaxies are that old, well, the spiral would have tightened so much that you wouldn't be able to see their arms. You wouldn't be able to visibly see them. So these are examples of what galaxies would look like if they were that old. They'd just kind of be disks. Their spirals would be so tight, you wouldn't really be able to see. Now, what this proves is that the galaxies must be younger than 500 million years old, which is still a much greater age than what we believe to be true. But it's a huge step compared to 13 billion years, and 10,000 years is younger than 500 million. Our next point will be Saturn's rings. Now this one, pay attention to this one, because this is one of the strongest arguments for a young universe. When you think of a planet with rings, Saturn is most likely the first planet that you would think of. But why is it the first planet that you would think of? Well, it has to do with what its rings are composed of, which is water and ice. Now, water and ice causes rings to be very reflective. It causes them to be bright, so we see them much easier. That's why everybody knows of Saturn's great rings. However, did you know that Jupiter also has rings? And so does Uranus, and so does Neptune. They all have rings, but they require much greater telescopes to see because they're much darker in nature, because they are not composed of water and ice. Well, the problem with Saturn's rings specifically is that because they are composed of water and ice, they are reflective. Now, if Saturn is millions of years old, then over the course of those millions of years, the rings should have been collecting space dust and micrometeorite debris. That would cause these rings to be much darker, just like Jupiter's rings, Neptune's rings, and Uranus's rings. That's the reason why we can't see those rings very well, is because they are darker and they're dirty in appearance. Now, the second problem, well, just to take a step back real quick, because these rings are composed of water and ice, and they are reflective, that points to them being very young, because over the course of millions of years, they would have collected this debris, which would have darkened them. So up to the second problem with Saturn's rings is the rate that Saturn is losing its rings. So Saturn is constantly being bombarded by meteoroids, which causes the rings to break apart into dust. Now, that dust gets sucked down into Saturn by its gravity, which is called dust rain. It's called ring rain. Saturn is estimated to be 4.5 billion years old because it was created with our solar system. Now, at the rate that Saturn is losing its rings, it would have to be younger than 100 million years old. Now, various secular studies have found that for these rings to be visible to our eyes, when we look in our telescope, the rings would have had to be younger than 10 million years old. Once again, much older than what we believe to be true. But what we believe still falls within the realm of possibility, and it's a much bigger step forward over 500 million years, which is a much bigger step than 13 billion. Now, our last topic for today will be on the James Webb Telescope. How many of you are familiar with the James Webb Telescope? Okay, a couple of you. So, this is what the James Webb Telescope looks like. Now, it is, I'll just tell you a couple things about it real quick. It's one of the most, no, it's not one of, it is the most powerful telescope ever made. Now, this telescope was designed by a group of people. It was designed by NASA. It was designed by an organization called ESA, which is European NASA, and another one called CSA, which is Canadian NASA. Now, all three of these organizations worked together to create this telescope, which this telescope's entire purpose is to take pictures of outer space and to take the highest definition photos the farthest away that we've ever seen. Now, it is 100 times stronger than the previous strongest telescope, which was called the Hubble telescope. And it was launched on December 25th in France, which December 25th of 2021, which was Christmas Day. So we are coming up on its 4-year anniversary of being shot into outer space. Now, this might be the most educational part of the lesson because it was launched in France, but it was launched in South America. France owns land in South America. Now, the James Webb Telescope uses infrared light to observe the universe. This is how it's able to take such high-definition photos of the universe. And it is also located about 1 million miles away from Earth. So scientists, what they were able to do is map out our universe and figure out a nice safe spot for it to sit, because this is the most expensive telescope we've ever built. They don't want it to just get destroyed or damaged in any way. So they have found a perfect spot for it, about 1 million miles away from Earth, and it sits perfectly in Earth's shadow, which means that the sun is not hitting it. This keeps it cold and preserved, so the heat won't scorch it, and it rotates with Earth as we go around the sun. So with all of that out of the way, now I can explain to you why it shows God. So the James Webb Telescope has been finding fully formed spiral galaxies that exist way too deep in outer space and way too close to this thing called the cosmic microwave background to exist. Now, you have to understand the Big Bang model and the Big Bang theory well to understand why this is important. So the cosmic microwave background is what we have observed. It is a real thing. What it is as we observe our universe with our telescopes, at some point, we hit this wall of radiation. And this radiation has caused, we can't see past it in our telescopes. Now, what atheists believe is that at one point, the entire universe, all of matter, energy, and everything, was smaller than a golf ball, and then it all exploded, and the universe is expanding since then. And so what they believe is because of how long it takes this light to reach our eye, it takes it about 13 billion years for it to get from where it is to where we are now. They believe that what we are witnessing is the early signs of the universe, which is when there was just radiation everywhere because all the energy was quickly expanding. Now, because they believe that what we are witnessing is the Big Bang, then there has to be a gap because, again, they believe that everything evolved over the course of millions of years. There has to be a gap between where this wall is and where we start to see the first stars and then where we start to see the first galaxies, because it would have taken millions and millions of years for all of that to form. Well, the problem is that they are finding these completely formed, completely spiraling galaxies right next to the cosmic microwave background. They're also finding fully formed stars even closer to it. Now, this completely throws a wrench in their entire timeline because it's not possible for these to exist. Now, we had our scripture reading this morning, and I would like to read it again in Genesis. This isn't a problem for us as Christians because we believe that God created everything all at once. He created all the stars at one time. So I'll read it. And God said, "Let there be lights in the expanse of the heavens to separate the day from night, And let them be for signs and for seasons and for days and years. And let them be lights in the expanse of the heavens to give light upon the earth. And it was so. And God made the two greater lights, the greater light to rule the day, and the lesser light to rule the night, and the stars. So we see God creating all of our stars at one time. This is what we would expect to continue to find as we get more powerful telescopes that can see even farther than the James Webb Telescope will be able to, is fully formed galaxies and fully formed stars existing equally across the universe. So, in conclusion, the next time that anybody asks you why you believe what you believe, or what proof you have for it, you can look up at the sky and you can use these 6 points and Genesis to prove your faith. Now, I hope that this has been helpful in deepening your faith and giving you a more foundational faith in which you can prove outside of the Bible, because you have to start in a place where the non-believer is at. They don't believe in the Bible immediately. And so you can't start with the Bible with them. So you have to start by using our everyday observations to show your faith. So I hope that this has been helpful for you. If you have been convinced by these scientific observations and have not yet believed today and wish to do so, well then feel free to come forward now, or find me or any elder man here, and we would be happily willing to help you in that decision while we come forward now and sing.